Okay, while this opens, I'll start recording. This is the test you did, I hope.
So we all got really excited because we're hoping you're going to walk set up a precision real test display.
Like a massive book.
So I've got to find out which question that people want.
It's got a boat and you can launch a missile up at 35 degrees, rates going 8 metres a second.
Oh, this one. Yeah, okay. So that's the question. So I can concentrate. First thing you're always going to do with this, guys, put your data down that you do know. Or data, depends which way you want to talk about it. So I can, what I have is a ship, and I'll just take a line like that. It fires a projectile at the same angle, which happened to be 35, and it was 250 kilometers per second, no, meters per second. So that's the actual diagram with it. I don't need to worry about the 8 meters per second one because we're only worried about the vertical motion of it, right? So then what I'm worried about is UY.
That's just going to be sine 30.
UY, yep, UY is the 250 sine 35.
That's not the whole question.
And when you do that, yeah.
No, because I wrote something
What's
for the
why?
first question. I wrote that they're in the same frames of reference, so that's why they were in
No,
the
there
same
was
line.
there's two parts to it, Brett. See, there's part A, which is writing, and part B, which is calculation.
Yeah. So you're doing part B or part A?
Like, you're part B.
Oh, okay. He was just writing part A, and I'm just like...
Yep. So, sorry, yeah, it should be down there. I just had it down there.
Just like, oh, yeah, it'll be down there.
No, it won't.
Never mind.
It gets stuck. So, my initial velocity in the vertical direction is 143.39 meters per second. Now I know that for this projectile, in its flight it's going to go up, it's going to reach a maximum height, it's going to come down again. I know at that maximum height it's halfway through its flight and Vy equals 0. Okay. I know also AY equals minus 9.8 meters per second squared. And as I said, Vy at max height is 0, and that's at delta y as I call it. So now all I need to do is choose the correct formula. V equals U plus AT will do it for me. So I end up with, if I rearrange that, the time taken to get halfway is V minus U on A, which is going to be minus 143.39 all over minus 9.8. And if you do that, you end up with a answer which is 14.6 seconds. But remember, that's only halfway. So total time of flight is that times 2.
Oh, so close.
Which is 29.2 seconds.
Mr. Croft, I did that question twice. The first time I got that answer.
That's like exactly the
Do I still get marks for it? Because I've wrote it down.
If you do the HSC
there's no work in that.
and you'd left it and then when you redid it, they'll give you full marks. If you cross it,
But I did.
then it's, I have to think about how they regard that one. That's what you should have done for it though.
Hey, so I wrote 30 because I rounded up.
Did you have any working?
No.
Well, then I can't give you marks.
That's the answer though.
What's going on here? It's a bit strange. It's really strange. Didn't want to.
Hey, sir, click on the pens button up the top.
Well, so if I get 0 marks,
Click on the pens category.
I can't see pens. Yeah.
Get it, and then go erase up. Now do stuff.
Does exactly the same. It's the way they erase. Well, it's related to that, but there's an experiment we can do around talk, guys. Talk is something that you boys often think they know a lot about because it's talked about a lot. And yes, I know. You can't get away from that one. So what would you boys say it was related to? Using the 2LS, it's to do with cars. So we can make a connection here with People like to relate to power, but be careful
Isn't it?
because,
It's in Newton meters.
right, so it's measured in Newton meters,
It's the maximum speed.
not the maximum speed. Now, look, I'll stress this. One of the things that physics students tend to do is we live in the real world and we use language in a fairly sort of we use things in a very imprecise way. In physics, we're very precise about things. So even though they talk about power has torque, and they talk about all these in Top Gear, they talk about all the horses that run away and all this stuff. In physics, we're a little bit more precise. It isn't measured in Newton meters. Now that gives you a hint about what's going on there. If you look at Newton meters, it tells you what two quantities are being multiplied together. So we have a symbol we used to talk, which is that, which is force, obviously for newtons, times meters, which is a distance, times distance. So in real terms, torque in physics is defined as the force times meters, or distance. Let's just take meters away if we rechange that to...
But when you use like a spanner to...
You're applying a torque.
Yeah, which
Because...
What actually is it for?
Thank you. Spot on. Who said that? Top of the class. So the real definition is torque is force being applied in a rotating system.
So in the car situation, you have a force being applied.
Well, when they measure the nanometers, yeah, they're measuring the amount of torque or how much push is being put against the road by the motor. So the capability of the motor to push the car along in very rough terms. Okay. Now, the reason we need to talk about this, I'm not going to be able to say it every time. The reason we need to have a discourse on this is because in motor vehicles, the thing that's actually making the car go along is the turning of the wheel, right? So you have a lot of force being applied on a very, very large wheel. It will do something to the way the car drives along. What will happen to it?
What was that, sir?
So if I have very large wheels, it will go very fast, but the engine will need to work very, very hard to get the speed, won't it? If you have tiny little wheels, you can apply more torque to the ground, so you can actually get out of very, very difficult situations, but you'll never go very quickly about it. Now, when we're talking about motors, or electric motors, the reason we need to discuss and understand this concept of torque, which we'll go into the next lesson, is because motors make things spin generally. When you look at a motor, the internal part of it is spinning, and it spins a shaft which is attached to something which makes something else happen. So we need to understand this concept. Thanks. Yeah, but it is possible to get what are called linear motors, where things travel along just in a straight line. But most motors we're going to deal with actually spin an axle, and we need to understand that simple concept of torque to do that. So next lesson, what we will do is I'll very briefly give you a demonstration of how torque works and how you measure it. And then we'll have we'll look at how it applies to a motor by measuring a torque caused by electric current through a magnetic field. And then we'll simply do some questions around that. Brad?
How does like a torque wrench work? Or like, you know, the ones where it
Torque
clicks?
wrench is extension, usually use that when you're replacing pieces inside of it.
Yeah, I know.
That's
Like,
a certain type.
Yeah,
I know,
and so
like,
what it does, it only applies so much force to that before a little clutch goes on it.
so it's a clutch mechanism that
It's a clutch mechanism that goes. But one area you see torque working is if you have a wheel nut that's stuck, and you use a normal spanner, you may not be able to apply enough force through that distance, get enough torque on it to turn the nut. So what you do is you get an extension bar on the end of your wheel nut, and you pull down on it. It might be 1 metre long, and that will be 10, 15 times. Because you can apply.
Because it's the amount of force that you're applying. So
through the distance from the centre of rotation.
Just hung off of it, so they're like the amount of force would be the same because it would be the weight hanging off it with mass times.
And because you're further from the centre of rotation, the torque's increased, which means you can get the nut off. Unless you have my car. No, I'm serious. My Stavic, they've especially used an alloy wheel with which literally undergoes a reaction with the nuts and fuses the nuts onto the alloy. And it gets so strong. I blew a tyre a while ago, and I tried to get it off with my wrench, my tyre lever. And I put an extension on. I was jumping on it, and that wasn't good enough. So I got that RMA out. They got their truck extension arm on it, and they couldn't get it off with that. And in the end, actually had to get they have a rattle gun, and they put it up to the highest rating they had on that, and it just managed to shift it off. So if you ever buy a Stavic, you get ready for the wheel nuts not to come off.
Samuel.
Samuel.